So we are back to the challenge results. Then I'm going to start. So first of all, thank you very much to all of you. We have had a very large participation. So we had, as I said before, 48 teams that were initially registered, that has registered their interest to the challenge, and with 70 potential pipelines. And so the number of final participants that were evaluated is actually 24 teams. And as you've seen in the teasers, it's representing something like 30 pipelines. And as Sorina has said before in her presentation, we have had an awful lot of messages to treat, but that was fine in the end. And as was mentioned by Francesco La Rosa from EPFL, we have only one non-deep learning pipeline this time. As a reminder, last time we had 13 teams in 2016 for MS lesion segmentation, and we had half of them that were not deep learning. So deep learning is really taking a large part now. So first of all, I have to really thank you, all of you, the participants in particular, for making this such a large challenge. So it's more than, I mean, it's almost twice the number of teams that we had last time. We have had teams from all over the world, unfortunately none from Africa, but all other continents are represented. We have some people from Korea, from Australia, from South America, North America, but still it's mostly coming from Europe. I have made a map a few days ago prior to the challenge. Some of you may have seen it somewhere in the Gaza town, and the address is there if you want to have a closer look on the repartition of the teams. Here is a screenshot of it though, and as you can see, really most of the participations are coming from Western Europe. But still we have some dots here and there. Now going further, so how did we do the evaluation? We have run the pipeline over the pipelines of each of the teams over the 60 patients of the testing set. The testing set was not seen by the challengers. All was done on the VIP platform at the end of July and beginning of August. And the computation of the evaluation metrics was done using the MICCAI perf analyzer. For those of you who participated to the first challenge, it's the exact same performance tool that we used in 2016, and it's available on Anima in GitHub. So we had two subsets of patients. It was the same actually in the training set. We had some patients that had no new lesion and some patients that had one new lesion or more. And so in the testing set, 28 patients had no new lesion and 32 patients, complementary, had one lesion or more. So based on this, we have done the evaluation using two sets of metrics, of course, because when you have no new lesion, this means that you have no ground truth, well, an empty ground truth. And because of that, the usual metrics, such as the dice score or, well, at least any overlap methods, are not working. So we really need to have dedicated metrics, and those metrics were actually quite simple. It's the number of new lesions that were detected by the automatic segmentation. So it's basically the number of connected components in the automatic segmentation. And the second metric is the volume of lesions detected in millimeter cubes. So that's for the case when you have no new lesion. The case when you have new lesions is the same as in the 2016 challenge. You have two classes of metrics, the detection metrics and the segmentation metrics. The detection metrics are actually answering the questions, are the new lesions found, so the new lesions in the ground truth found regardless of the precision of their contours. And the segmentation metrics are more looking at the precision of contours. Are they found regardless of if there is a lesion missing or not? So the first class, the detection metrics, is really the most crucial from a clinical point of view, because as Ankerba has been showing before, it's really the number of new lesions that is important in changing therapy or changing medication. So there is a total of 15 metrics in the MSSEG-2 analyzer, but we kept only 2 for ranking. It's the F1 score for the detection and the DICE score for the segmentation. So just to illustrate those metrics, the DICE score, most of you know what this is. It's a volume overlap metric between 0 and 1. 0 means no overlap between the automatic segmentation and the reference. And 1 is a perfect overlap. So it's basically a ratio between the true positives and all other quantities, true negatives, false positives, false negatives. The F1 score is based on the counting of true positives, false positives, and false negative lesions at the lesion level. So this time we're not counting at the voxel level, but the lesion level. And the F1 score is a combination, you have the formula at the bottom, it's a combination of the positive predictive value and the sensitivity at the lesion level. So it's the same formulas, but except that we have counted at the lesion level. And so again, for the F1 score, 0 is no lesion was found, no true lesion at least. And 1 is all lesions and only them were found. So with this, now we have to rank participants. I don't really like to do rankings because I find sometimes it's not the goal of what we do in research. But let's say that for a challenge, it's something that you do. So we have a simple ranking for each metric that is made by averaging the results for each participant over all patients. And we rank this average results for a given metric. And so in the future, we'll have box plots of all results for all methods. Here I will show only one for the F1 score, the most important. So before I go on to the rankings, we had a few specific cases that I would like to mention. For one team, the pipeline execution has actually failed on most patients or was with wrong image sizings in the end. So it is the pipeline from MSSEG-lesions MS, and so it's not considered this time in the ranking. It's not due to the fact that the method was wrong, it's due to Docker implementation difficulties, and we can talk about this in the discussion. I think some of you may have experienced difficulties in doing the Docker implementation and integration in our platform, so we're really happy to have feedback on this. One pipeline was also having weird results. It's the one from the ITU team. It found lesions, but they are often below 3 millimeter cube. So because of this, the results of detection are mostly 0 because we remove the lesions that are small and particularly below the 3 millimeter cubes threshold. So do not worry because you have zeros. We can talk about it later. It might be perfectible. It may be perfectible. And so finally, as Sorina mentioned in the beginning, for several teams, one patient has failed, random patient, not always the same one. And so these teams are ranked as well, but they are marked with a star. So now let's go with the results. First of all, with the results on the no lesions subset. So I'm first showing the number of lesions that were detected by each of the methods. One thing I forgot to mention is that in each of those tables, I'm going to show the experts as well, to show how the experts perform. So this time I'm showing the average number of new lesions detected. The best score is of course 0. So there is only one expert that actually reaches this average 0 number. And the 4 teams that are performing best are LILE, SCAN, NeuroPoly-2, and PVG, which have a quite small number of new lesions detected on these cases with no lesions. All the others, though, are actually having very acceptable results because we really have to go until the end of the table to go above an average number of 1 new lesion detected. So that means that for a lot of patients, all teams are actually detecting 0 lesions. I'm having difficulties switching slides. Going to the volume of lesions, so the second metric for the no lesion subset. Again, we see the same names coming up. It's LILE, NeuroPoly-2, and PVG, which are sharing the 3 first places. In this case, the volume of lesions, we see that LILE and NeuroPoly-2 are actually above 3 of the experts, meaning that some of the experts detected some lesions were relatively big in some patients and that were not in the ground truth in the end. So even in the experts, we have quite a lot of variation. Going now to the results on the lesions subset, so the subset with lesions. I'm going first with the DICE score. I'm going to finish with the most important one, the detection. For the DICE score, so really, is the segmentation performed well, but you might miss some lesions. The 3 experts this time, 3 of the 4 experts this time are in the first place, and it's MedICL, Labri, IQDA, and SNAC that are performing the best. One thing we can note on this DICE score is that actually the value of the DICE score is quite low compared to what you would be seeing in single time point segmentation. So that really means that the segmentation is much more difficult in that case. Even for the experts, the best score is 0.63, which is not that much for an expert. Next, going on to the detection now, which is the final score on the lesion subset. We have again the 3 experts that are above the others. Mediair has been performing quite well. I'm including a 4th one because Mediair has 2 pipelines. So Mediair is 1st and 3rd, MPen is 2nd, and Library IQDA again is 4th. And 3 of these teams are actually above the 4th experts, which is actually quite different from the challenge we've seen in 2016. So these are some results. I'm not going to show actually image results because these are there are too many teams to show, so I'm not able to show it in one slide, but I will share the data as soon as possible. In analyzing a bit more the differences in detection, so first of all, we see a lot of variation between the teams. This is a box plot of the different teams, and each dot is a single result for each team. So we see that for most of the teams, we range between 0 and 1, the 0 and 1 included. This comes from the fact that there is a lot of variation in the result, but also from the fact that the metrics, especially the detection one, is sensitive to the number of lesions, and it's when there is only one lesion, it's going to vary much more than much faster, sorry, than if you have let's say 40 lesions. So meaning that in the case of one lesion, you're going to switch between 0 and 1 very fast. If I go a bit further in the analysis, I don't know how much time I have left, 10 minutes. There is a dependence. I mean, we wanted to see if there is a dependence to the number of new lesions. And so we plotted in this scatter plot. Each blue dot is an average for one patient of the F1 scores of all the methods that we have tested. So the 30 methods we have tested. The orange dot is the average, but this time for the experts. And what we see is that there is a lot of variability when you have only in between 0 and 5 lesions. And when you go to more lesions, the numbers are actually much higher and much more stable. We have also more cases where we have only 1 or 2 new lesions. If we go now to detection rates in different tissues, it's really a preliminary results that I'm showing you. What we've done is to have a segmentation into subparts of the brain of each patient. And now we are identifying if we have false positives or false negatives, if you have more of them in the deep white matter, the brainstem, or the cerebellum. What we see, and that would be expected, I guess, because as some of you have mentioned, there are always more samples in the deep white matter. The results of the true positive rate are better in the deep white matter and worse in the brainstem and the cerebellum. And the false positive and false negatives rate are actually not so dependent. You have a 70% of false positive rate, which is quite high in the deep white matter, only 40% in the brainstem, and an enormous number of 125% of false positive rates. What I've not mentioned is that this ratio is computed over the number of lesions that are in the patient parameter. So that means really that in the cerebellum, all methods overall have a lot of false positives. We wanted also, and that's the final slide of this preliminary analysis, I think, to see if there is a change on the unseen manufacturer. So as I mentioned in the very first slides of the afternoon, the GE scanner images were actually left unseen to the challengers. They were only in the testing set. What we've seen also, however, in analyzing is that this represents only 9 images. And actually 6 of them are without lesions and 3 are with lesions. So the numbers I'm showing here are not very conclusive, statistically speaking, because there are not so many images in the end. And so the statistics are really difficult to make. And what I'm showing is that basically there is not so much difference. There is always degradation of G versus non-G. But this is happening for all automatic methods, but also for the experts. So that means that it's maybe not only from the change of manufacturer, but maybe something else as well. But again, the GE cases are only 3 images, so these are to be taken with precaution. So finally, what are the take-home messages? A few of them. So MS new lesions detection and segmentation is an extremely difficult task, even for the experts, because you have disputed lesions, and we needed in the first place to have an external consensus review expert. The growing lesions are also difficult to distinguish from the new lesions. Sometimes you have new lesions that are just next to another lesion that can be taken as a growing lesion. The number of lesions does influence the results, but not completely, I would say. And in terms of detection and segmentation, we have results that are actually different from the 2016 challenge, where all experts were above the methods. This time, the 3 or 5 best teams, depending on the metric, are above at least 1 expert. But the 3 experts that are above all methods are way above all methods. So there is still some room for improvement, I would say. Let's talk about the future, and then I will leave the next slides for the discussion. So we would like to do, of course, more analysis. This is very preliminary. We've done this over the months of September, so of course there is much more to do, and we're happy to hear from you if you have any ideas. There is a question about metrics, meaning is it really useful to count precisely the number of lesions? As Anne-Claire has shown in the slides, when you have, for example, 15 lesions, is that really important to count all of the 15 lesions, or just knowing that there are more than 3 new lesions is the important thing to know? So there might be new metrics to show to actually, show these points. So we propose, but this is still something we are thinking of, to continue the challenge evaluation platform afterwards, after the challenge, to have a fair comparison of new methods. But at the same time, we think of opening the data. So I will show that afterwards. We are going to release all the results materials of the challenge. The figures are going to be shared as a Zenodo repository very soon. The individual results segmentations of the challengers are going to be shared first to the challengers themselves, but then probably to the world. And we are opening, and I will finish on this right now, we are opening a research topic on the topic of multiple sclerosis new lesions segmentation. At Frontiers in Neuroscience, you have all the participants at least have been contacted right now to know if they are interested. The paper submission deadline would be at the end of June next year. And in terms of data and proceedings, the proceedings with all short papers in are going to be released soon, the time for us to gather them together. And the data, the training will be open to everyone upon signing the data usage agreement on Chat Noir, and all data will be, including the testing set, will be released to the challengers and to persons participating to the research topic soon as well. So I'm going to take questions right now about these results, and then we can move on with the discussion and the end of the challenge day. Please, if you have any question, you can ask them in the chat or take the mic and just ask your question. Thank you. So I see actually 2 questions in the chat. I don't know if you two who have written the questions are still there.
Hi, Olivier. I wrote the first question.
Sure.
Just wondering, some of the pipelines obviously use external data, and was wondering if that's taken into consideration. Because that makes the comparisons difficult, doesn't it?
Yeah, that's something we have been wondering for this challenge and for the previous one, actually. We have considered them at the same level as the other pipelines, but it's true that if you have more training data, it's probably helping you. Then this additional training, the reason we have also considered them together is that the fact that you have more data is good in a sense, but also can be misleading your algorithm, because the ground truth that we're using is probably not made in the same way that the ground truth that you're using in your additional data. So that's one reason, but then we have encouraged over the years in those challenges to have those people who are using additional data to at least mention it, of course, but also to have two pipelines, one with only the training set that we have given, and another one with more data. So, that's my answer.
I think it could be useful just to mark them with like an asterisk or something, so that you can see if they stand out as outliers.
True. This is something we could do. We could highlight them in a way.
Thanks.
That's true. In any case, we have asked all the participants to give information about whether they were using additional data or not. So we have this information and we can definitely highlight them.
That sounds good, thank you.
Okay, I see a hand raised and two other questions in the chat. So let's go maybe with Naga Kartik.
Yeah, hello. Yes, thank you for the presentation. So, my question is not very technical. I was just wondering, I think I couldn't get the names of the first two, the metrics that were shown. So the last two were DICE and F1 score. And what were the other two? And
so those two maybe?
Yeah, okay. So this is the
lesion subset.
Okay.
So it's the ones that we've used on the 28 patients that didn't have any new lesion. So in that case, of course, the DICE and the F1 score are meaningless.
Mm-hmm.
So what we've done is that we've computed the number of lesions in the automatic segmentation. So it's basically an integer number, which is the number of connected components in the automatic segmentation. And the second one is, regardless of the number of lesions, it's the total volume of lesions in the automatic segmentation that you obtain. So those are the two metrics for the no lesion subset. It's really simple, simple ones to see if there is something in the automatic segmentation when there should be nothing.
Okay. Okay. Thank you. Thank you very much.
You're welcome. Then we have a hand raised. It's Marwa Ahmed. Maybe. Disappeared. Otherwise, we can go with Stella there. Yeah, let's go with Stella if she's here.
Okay. Okay, thank you, Olivier, and to all the organizers for a very, very well organized challenge and a very important one. And I know it's very, very hard to run this kind of challenge. So I really wanted to thank you. And thank you for continuing it after today. So I just wanted to echo also my sentiment that I think it's important to kind of separate those people that use prior data and also potentially pre-trained networks on a large data set that can easily be fine-tuned or can be fine-tuned to this problem, just to be able to see the effect even of that on the results. I think that would be interesting and important. So my question is, you had mentioned that you removed tiny lesions. I was just wondering if you removed them from ground truth and also from everyone's detected results, just because if you removed it from ground truth, so to speak, something an expert found is, and then a method actually found a tiny lesion, is that a false positive or is it removed from both?
Yeah, well, yeah, the answer is yes, we remove it from the ground truth and from the individual results of the participating teams. Which is why, by the way, the ITU pipeline didn't get good results. It's because they have new lesions detected, but for some reason that I don't know, I've not discussed with them, their segmentation is actually quite a small point in the center of the lesion. And so because of that, because we then remove those lesions that are small enough, their results are bad because of this. It's not that their method is failing, it's producing too small lesions. So, and in the ground truth as well, we're removing those 3mm cubes lesions.
Okay, all right, thank you. I was just wondering, because you had also mentioned that you could potentially review some of the false positives. I'm wondering if that's something you're interested in, if, for example, potentially people found with their methods lesions that maybe could have been missed by experts.
Yeah.
If that's something you will review.
Yeah, we've seen in the teasers and in the short papers as well, some persons that have been mentioning that they found lesions that were not in the ground truth. Mm-hmm. So even in the training set, and I'm pretty sure that it happens in the testing set as well. So I don't know exactly how we're going to do it right now, but we want to have the same expert senior radiologist looking at the lesions that were found by let's say, at least 2 or 3 automatic pipelines, and having him telling if it's really a new lesion or not, to see the added value, because we see a lot those kind of artificial intelligence algorithms that say, we have had some people look at the lesions that we produce and we see that we have something new compared to the human eye. So we want to see if it's the case with the new lesions in multiple sclerosis as well. So that's something we want to do. I don't know if it's going to be done very fast, because we have to find a radiologist that has time for it, but we want to do it.
Yeah, that would be great. Thank you. There's one last, not to hog that discussion, one last just point about counting. So we are working on counting as well in terms of bins. We've worked on it. Basically, you'd have 0, 1, 2, 3, 4 plus or something like that. But you're right, there needs to be new metrics, because of course the difference between 0 and 1 plus is the main difference. You don't want to make a mistake in that area, and it becomes actually less important when you go from, let's say, 3 to 4 or 3 to 4 plus. So there needs to be a metric that accounts for that, and that's something we're also dealing with.
Yeah, that's something we're thinking of. I don't know exactly how to evaluate this, but we should see with the clinicians what is really important. I think the 0 to 1 is clearly one that we don't want to miss. But we should fix some thresholds and adapt the metrics for that. It sounds doable to me, so that's...
Yeah, the other way too. Anything above 1 to 0 is also a problem.
Yeah.
Yeah. Okay. The distance to the boundary is also, so that's an issue. So if you say 5 and there was 0, it's different than 1 and it was 0. There are many things to consider. So.
Yeah. Well, that could be several new metrics, but then we have to... People like to see one metric evaluating. That's why we're showing only 2 or 3 metrics, even though we have 15 already. But I mean, we have to choose the right ones to show to the clinicians that really talk to them.
Yeah. Okay. Well, thank you. Thank you very much, Olivier.
Thanks. Are there any other questions, remarks, anything? We are going slowly to the discussion session. There is not much more to be mentioned on our side. I'm just going back to the end of the slides. What I didn't mention though right now is that I would like to thank everyone, the participants, the audience, in particular OFSEP, FLI, VIP, MPEN, and the new Afro team. That's a lot of people. I'm not going to mention all their names. But they have worked really hard, especially during the summer, which is not really easy for everyone to be there and work when there is no one else. So that's it.